Namaste and welcome back. This is a four-part series with one job. Not to explain the dMAT, to sit with you and solve the hard questions, the ones that decide your score. The running order. 1. Figure sequences, done. 2. Mathematical equations, done. 3. Latin squares, done. 4. The general academic module, today. After today, you have seen the whole exam. And I have saved the biggest for last. The 3 core subtests get 25 minutes each, 75 together. The subject module gets 90. One module longer than the other 3 put together. That is where this exam is won. One thing first, and it takes 10 seconds. We post a dMAT practice question on Instagram almost every day. One question in your feed while you are already scrolling. The handle is on screen. Go and follow it now before you forget. And 30 seconds on how to practice properly. Every paper in our mock series is 90 questions in 165 minutes, with the subject module timed exactly as the exam times it. 10 papers. And the sample test is free. 20 questions, no card. That is the last you will hear about it. The rest of this hour is teaching. Here is the hour in 4 lines. 1. How this module works. The official rules in 3 minutes. 2. The official example on screen solved together. 3. 4 texts of my own. 4 subject areas. 5 questions each, harder than the official set. 4. And each of those 4 texts teaches you one technique. By the end, you will not be reading these texts. You will be hunting in them. What is in front of you is a text, a real one from a textbook or a report, and then questions about it. Now, the sentence people get wrong. You will hear that this is not a knowledge test. That is not quite what the official document says. Page 5. It requires quoting, subject knowledge, and application skills, but not memorized factual knowledge. So you need to think like a graduate in a technical field. You do not need to have remembered anything. Every constant formula and definition a question depends on is printed in the text. The mechanics from page 33, 4 options per question, exactly 1 correct. And the text, the questions and the options may all contain figures, tables and formulas. That is not decoration. In 3 of the 4 official examples, the table is where the answer lives. 90 minutes for the whole subject test, and here is the line people skip. You are not allowed to take notes, not on paper, not anywhere. Formulas and nothing to write on. Holding the working in your head is not a side problem, it is the difficulty, which is why all 4 techniques today need less working, not more. One more and it is a gift. The official instructions say in plain words, if you do not know an answer, guess which answer might be correct. There is no penalty, so there is never a reason to leave a blank, not one. And after today, you will rarely be choosing between 4, you will be choosing between 2. Now the part that frightens people. Mathematics, computational sciences, natural sciences, engineering, business administration, economics, social sciences, and humanities. 8 areas, and you do not choose which one turns up. An engineer can open the paper and find a text on qualitative research methods. Here is why that is survivable. The text is a closed world. Whatever you need is inside it, and whatever is not inside it is not being asked of you. The humanities text is not testing whether you studied humanities. It is testing whether you can read carefully under a clock. That is a skill, and a skill can be trained in an hour. One decision costs people 10 minutes every time. Text first or questions first? Neither, quite. Read the text once, but for furniture, not for content. Where is the formula? Where is the table? What is each paragraph for? You are drawing a map, not memorizing a page. Then let each question send you back to the right part of it. You cannot take notes, so the map in your head is all you get to keep. Make it a map of locations, not of facts. 4 techniques, so you know where we are going. 1. The sentence that decides. 2. Split the option. 3. Move the lever. 4. Type, then size, then value. None of these are mine. I took all 4 out of the official document by working every question in it and asking what each was really testing. And the order matters. The first works on any text in any of the 8 areas. Let us open that document, not my version, the real one. Page 33 of the official preparatory materials as at the 4th of August 2026. General instructions. A text and a number of questions. 4 answer options. 1 correct solution. Figures, tables and formulas. 90 minutes. No notes. And guess if you do not know. And at the bottom, the 8 subject areas. Everything I just told you is on this one page. Download it. The link is in the description. Page 34, exercise 1, vector calculations. And this is the shape of the thing. A text, a figure, a table, and 8 questions hanging off it. Read it for furniture. Paragraph 1. What a vector is. 2. How vectors add and what multiplying by a scalar does to the length. 3. The length itself from Pythagoras. Not one of them asks you to remember anything. Then the figure. A vector on axis with its length worked out beside it. Mark where it is. 2 of the 8 questions need a number that exists only in that picture. And the table, which is the engine of the exercise. 3 rows, scalar product, vector product, triple product, for each, the notation, and the rule. Everything the 8 questions ask you to compute is in those 3 rows. Nothing is tested from memory. It is tested from that table, under a clock, with nothing to write on. Map drawn. Let us do one together. Official question 2. What statement is true when a vector is multiplied by the number -2? And look at the options before you think about vectors at all. The length doubles or halves. The direction stays or reverses. 4 options, but only 2 decisions. So do not answer the question, answer half of it. The length. The text says a scalar multiplies every component and a scalar greater than 1 stretches the vector. The size of -2 is 2, so the length doubles. Both options that say halves are gone. 2 dead on 1 decision. Now the direction, and now it is a choice between 2. -2 is negative, so every component flips sign and the arrow turns around. Doubles and reverses. The official answer is C. One more, stranger. Official question 3. The type of result from the 3 operations is not always the same. Which statement is correct? Every option is the same 3 claims in a different combination. Scalar product gives, vector product gives, triple product gives. Notice what this is not asking. It is not asking you to calculate anything. It asks what kind of thing comes out, and the names hand you 2 of the 3 for free. A scalar product gives a scalar, a vector product gives a vector. So only the triple product is in doubt, and the table settles it. The triple product is a scalar product taken with a vector product inside it. The last operation performed is a scalar product, so the result is a scalar. Scalar, vector, scalar. The official answer is B. Not one number calculated. We come back to that in the last passage. 2 official questions. Look at what happened in them. In the first, you cut 4 options to 2 by answering the half you were sure of. In the second, you answered without calculating because you asked what kind of thing the answer had to be. That is not luck, and it is not my invention. That is the examiner's own material telling you how it wants to be read. Now 4 texts of my own, each turning one of those instincts into a technique you use on purpose. Technique 1. The sentence that decides. The rule is 4 words long. Find the sentence first. Every answer here is a sentence in the text, not a summary, not the gist, a sentence. And the examiner agrees, which you can check. Official exercise 4. Every one of its solutions ends the same way. See paragraphs 1 and 2. See paragraphs 4 and 6. 2 traps punish not doing it. First, an option that is perfectly true about the other thing. Second, and nastier, a true conclusion with a reason the text never gave. You nod at the conclusion and never check the because. Text 1. Subject area humanities. Chosen deliberately because most of you are engineers, and this is the text you fear most. Historical linguistics. You know nothing about it, and in 9 minutes, you will answer 5 questions on it correctly. I will not read all of this. It is on screen. I am marking the sentences that decide questions. Paragraph 1. Inherited words come down without interruption from the parent language. Borrowed words arrive later from a neighbor after the split. Paragraph 2. What a sound law is, and its defining property, regularity. Inside its period, it applies to every word that meets its condition, not word by word, no exceptions. Paragraph 3. The law we have. In language P, every word initial P became F. With the consequence the text spells out, an inherited word of P cannot begin with P. And when a law stops working, it has lapsed. Words arriving after the lapse are untouched by it. Paragraph 4 is a clock. A loan word that shows the effect came in while the law worked. One that does not show it came in afterwards. Paragraph 5 decides the hardest 2. Core vocabulary. Kinship, body parts, low numbers, resists borrowing. Cultural vocabulary is borrowed easily. Then the sentence, people skim past. That resistance is statistical and not absolute. Under intense contact, core vocabulary can be borrowed too. And the table, Fater and Pater, Piper and Piper, Fisk and Pisk, Pund and Pund. Question 1. Which statement about sound laws is supported by the text? Options on screen, read them. supported by the text. Those three words are the whole instruction. So do not ask which sounds most like linguistics. Ask which is a sentence I have read. Paragraph 2 gave the property in one word, regularity, then said what it means. Every word meeting the condition, no exceptions inside the period. Option D is that sentence in different words. Option D. And look at option A, the trap in its purest form. Phonetically natural. It sounds like something a linguist would say. It appears nowhere on the page. You brought it with you. Question 2. The word piper, meaning pepper, begins with P. What does the text let you conclude? Options on screen. 2 steps, both sentences I have already pointed at. Paragraph 3. An inherited word of P cannot begin with P. Piper begins with P, so piper is borrowed. That kills option B. Step 2 is only about when. Paragraph 4 is the clock. A loan word that does not show the effect came in after the lapse. Piper kept its P, so it came in afterwards. Option A. Question 3, and this is the one to remember for the rest of your life. Which of the following conclusions is not supported by the text? Read all 4 carefully. This one rewards it. 3 are supported and 1 is not. So read every option for its reason, not only its conclusion. A is supported. Fisk has F, where the sister language has Pisk. B is supported. Punt kept its P, and paragraph 4 dates an unaffected word to after the lapse. D is paragraph 5, almost word for word, which leaves C. And the conclusion in C is true. Fater almost certainly is inherited. But read the because. It says fater is inherited because it is core vocabulary. And paragraph 5 said resistance is statistical, not absolute. So the class never proves anything about a single word. What proves it is the shape, the F. A true conclusion, resting on a reason the text does not give, is still unsupported. Option C. That is trap 2, and it will cost you marks in every subject area until you learn to read the because. Question 4. A fifth word of P, fenestra, meaning window, is known on other grounds to be a loan word. What follows? Options on screen. We are told it is borrowed, so the only question left open is when. Back to the clock in paragraph 4, and notice it reads in both directions, shows the effect, came in while the law worked, does not show it, came in after. Fenestra begins with F, so it shows the effect. It was already there while the law was still working. Option D. Question 5, the hard one. Suppose P also contains the word pater, also meaning father, alongside the fater in the table. Which single explanation is consistent with everything in the text? 4 options. Take your time. Consistent with everything. That word means 3 separate sentences have to hold at once. Paragraph 2 removes the easy way out. A law has no exceptions in its period, so it cannot have caught fater and missed pater while both sat there. Option B is gone. Paragraph 3 decides which is which. Pater begins with P, so pater cannot be the inherited one. Option C is gone. Paragraph 5 clears the last obstacle. Father is core vocabulary, so option D feels safe. But resistance is statistical, not absolute. Resists is not cannot. Option D is gone. So the word was inherited once, becoming fater, and the same original word arrived a second time from the neighbor after the law had stopped working, arriving as pater, keeping its P because there was no longer a law to catch it. 1 word, 2 arrivals, centuries apart. Option A. 5 questions in a subject none of you have studied. Question 1, a sentence. 2, 2 sentences. 3, reading the because. 4, 1 sentence, read in the right direction. 5, 3 sentences at once. Not one fact from outside the page. That is the technique, and it works in all 8 areas because it is not about the subject at all. Technique 2, split the option. You used it already on official question 2 when you decided the length before thinking about the direction. The rule. When an option makes 2 claims, it is wrong if either half is wrong, which sounds obvious and has a consequence that is not. You never have to be sure of both halves, only of one. And this shape is everywhere in the official set. Exercise 1, question 2, exercise 3, question 1, exercise 2, question 5. So the move never changes. Pick the half you are surer of, kill everything that fails it, and only then think about the other. Text 2, subject area natural sciences. Chemical equilibrium and how a system answers back when you disturb it. Every question on this text has compound options. Every single one. Paragraph 1. Equilibrium is not stillness. Forward and reverse running at the same rate, concentration steady, both reactions carrying on. Paragraph 2, and mark this heavily because it decides 4 of the 5 questions. The equilibrium constant K depends on temperature and on nothing else. Nothing else, not pressure, not concentration, not catalysts. Paragraph 3 gives the principle. Disturb a system at equilibrium and it shifts in the direction that partly opposes the disturbance. Pressure, squeeze the volume, and it moves to the side with fewer moles of gas. And separately, raising the pressure by adding an unreactive gas at constant volume changes nothing because the partial pressures of the reacting species do not move. Temperature, raise it and it moves in the endothermic direction. And because temperature is the one thing K depends on, position and constant move together. Catalysts, equilibrium sooner, position unchanged, K unchanged. And the reaction, nitrogen plus 3 hydrogen to 2 ammonia, enthalpy change minus 92. 2 facts live in that line, 4 moles of gas on the left, 2 on the right, and the minus sign means forward is exothermic, so backward is the endothermic direction. Question 1. The pressure is raised by reducing the volume at constant temperature. What happens? A. Towards ammonia, K unchanged. B. Towards ammonia, K increases. C. Towards the reactants, K unchanged. D. Towards the reactants, K increases. 2 claims in every option. A direction and something about K. Take the half you are surest of. K is the easy half. K depends on temperature and nothing else, and the temperature is being held constant, so K cannot have changed. Options B and D are gone, and we have not touched the chemistry. Now the direction between 2. 4 moles of gas on the left, 2 on the right, and squeezing favors the side that takes up less room. That is the ammonia side. Option A. Question 2. The temperature is raised at constant volume. A. Towards ammonia, K decreases. B. Towards ammonia, K increases. C. Towards the reactants, K increases. D. Towards the reactants, K decreases. Split it again, but notice first that this time the halves are not independent. Paragraph 5 said so outright. A temperature change moves the position and the constant together. So settle the direction and the constant follows for free. Forward is exothermic, that was the minus sign, so the endothermic direction is backwards. Heating shifts it towards the reactants. Less ammonia means a smaller K, and the halves agree. Option D. That is the refinement worth keeping. When the halves are linked, the one you are sure of hands you the other. Question 3. A catalyst is added at constant temperature and volume. A. Yield increases, equilibrium sooner. B. Yield increases, K increases. C. Yield unchanged, K decreases. D. Yield unchanged, equilibrium sooner. Paragraph 6 answers both halves of every option in one sentence, so this is fast if you found the sentence. Sooner. Yes, it lowers the activation energy both ways equally. Position and K unchanged, both of them. Unchanged and sooner. Option D. Option A catches people because it is right about the sooner. A catalyst is not a way of getting more ammonia, only of getting to the same ammonia faster. Question 4. Argon, which reacts with nothing, is pumped in at constant volume and constant temperature. A. Pressure rises, no shift. B. Pressure rises, shifts towards ammonia. C. Pressure unchanged, no shift. D. Pressure rises, K falls. The easy half is the total pressure, and it needs no chemistry. Gas has been added to a container that cannot expand, so the pressure must rise. Option C dies on that alone. Now, the second half, and this is the sentence I told you to mark, the last one in the pressure paragraph. The partial pressures of the reacting species are unchanged. Argon takes part in nothing. The nitrogen is still at the pressure it was, and so are the others. And with temperature constant, K cannot move either, which kills option D. The reaction cannot tell anything happened, no shift. Option A. Option B is the trap in one line. It assumes the equilibrium responds to total pressure. It responds to the pressures of the species taking part. Question 5, and this one has a sting in it. An engineer wants the largest possible proportion of ammonia at equilibrium and does not care how long it takes. Which statement gives both suitable conditions and a correct reason? Read all four. Conditions and reasons are both in play. Read the stem again, both suitable conditions and a correct reason. So 3 claims in every option, not 2, and all 3 have to hold. Conditions first, and you have done this work. High pressure moves us towards ammonia, the side with fewer moles of gas. Low temperature moves us towards ammonia because forward is exothermic, that kills options B and C. And it leaves 2 options that name exactly the same conditions as each other. So the conditions cannot separate them, only the reason can. Option D says, because K does not depend on temperature. Go back to paragraph 2. K depends on temperature and on nothing else. That reason is the exact opposite of the one sentence I told you to mark heavily. Right conditions, false reason, dead option A. By feel, that was a 50-50 between 2 options that look identical. Reading the because made it certain. In 4 of those 5, one half of the option killed 2 choices before the difficult half was touched. In question 4, the easy half killed 1 before any chemistry at all. Split the option, be sure of one half, let it do the work of both. Technique 3, move the lever. This is for every question with a formula in it. The rule, read the formula as proportions, not as arithmetic. What is on top grows the answer. What is underneath shrinks it, and the exponent is the length of the lever. And this is not a study tip, it is in the official document. Exercise 3. Question 2 asks, what could make the order quantity rise? Question 5. What happens if the ordering cost doubles? Question 6. What happens if the goods become more valuable? 3 questions out of 7 and not one wants a number. The answer to question 5 is root 2 because that quantity sits under a square root, half an exponent, half a lever. Text 3. Subject area, engineering. The stiffness of a cantilever, a beam clamped at one end with a weight on the other. I picked it because it contains 2 cubes that fight each other. Deflection is how far the free end drops under load. E is Young's modulus about the material. I is the second moment of area about the shape. Material and shape kept separate. And that separation is why these questions are answerable. And here are the formulas. Look at them as shapes before mathematics. The deflection is the load times the length cubed over 3EI. So, load on top, first power, length on top, cubed, modulus underneath, second moment of area underneath. The second moment of area for a rectangle is the width times the height cubed over 12. And paragraph 3 tells you which is which. The height is the one measured in the direction the beam bends, and the height is the one that gets cubed. The text says why. For bending, where the material sits counts for far more than how much of it there is. And a note underneath, which we need at the very end. For a square cross-section, width and height are the same letter. So the second moment of area goes as the side to the 4th power. Then the table. Steel 210, aluminium 70, timber 10. Friendly numbers. 210 over 70 is exactly 3. That is not an accident. The examiner wants you reasoning, not dividing. Question 1. The length of the cantilever is doubled. Same load, same material, same cross-section. The deflection becomes A. Twice as large, B 4 times, C 8 times, D unchanged. Find the letter that moved. Only L. Everything else can be ignored. And ignoring things is the whole point. Which way? L is on top, so it grows the answer and the beam sags more. That kills option D. How hard? L is cubed. The exponent is the lever. Double a quantity that is cubed and you multiply the answer by 2 cubed. 8. Option C. And you never touch the table or the cross-section. 15 seconds once you stop trying to calculate a deflection. Question 2. A steel cantilever is replaced by an aluminium one of the same dimensions and at the same time the load is halved. Using the table, the new deflection is about A. 0.67 times, B. 1.5 times, C. 3 times, D. 6 times. 2 levers move at once, so move them one at a time and multiply at the end. Never both together. You cannot write anything down. First, the material. E falls from 210 to 70, a third of what it was, and E is underneath, so a third underneath is 3 times the answer. Now the load. F is on top, first power halved, a factor of 1/2. 3 times 1/2, 1.5, option B. Question 3. A cantilever has a rectangular cross-section, 20 millimeters wide and 60 high. It is turned on its side, now 60 wide and 20 high, and loaded as before. The deflection becomes A. 1/9 as large, B 3 times, C 9 times, D 27 times. Nothing outside the cross-section changed, so the whole question is what happened to the second moment of area? And before any numbers, the mechanic, because this is what decides it. The height is measured in the direction of bending, and the height is the one that is cubed. Turning the beam on its side does not change the amount of metal, it changes which dimension does the cubing. Before, 20 times 60 cubed, after 60 times 20 cubed. Divide one by the other and you get 60 over 20, but only squared because one factor of 60 is cancelled by the 60 that moved to the front. 3 squared, 9, so the second moment falls to a ninth and it is underneath, so that is 9 times the deflection, option C. This is why a floorboard on edge holds you and the same board laid flat does not. Same wood, 9 times the sag. Question 4. A designer must double the length of a rectangular cantilever while keeping the deflection under the same load exactly as it was. Only the height may change. By what factor must the height increase? A. Root 2, B 2, C 4, D 8. The same formula run backwards. Put the two formulas together first so the levers can see each other. Deflection goes as length cubed over the second moment of area, and the second moment goes as height cubed. So deflection goes as length cubed over height cubed. Both cubed, the same cube. For the deflection to stay put, that ratio has to stay put. And because the exponents match, they cancel completely. Length over height must simply not change. Double the length, double the height, option B. The answer is 2, which anyone could have guessed. But what you did was notice both exponents were 3, and that is what stops you reaching for option D. Question 5, the hardest lever in this video. Two cantilevers of equal length have the same stiffness. Beam A is steel, square cross-section of side A. Beam B is timber, square cross-section of side C. Using the table, the ratio of C to A is about A 1.5, B 2.1, C 4.6, D 21. Stiffness goes as E times the second moment of area and the lengths are equal, so length drops out. The whole question is E times I for two beams. Now the mechanic, before any number, the note underneath the formula. For a square section, width and height are the same letter, so the first power and the cube are both supplied by the side. 1 plus 3 is 4. The second moment goes as the side to the fourth power. Equal stiffness means steel's modulus times A to the fourth equals timber's modulus times C to the fourth. Rearrange and C over A to the fourth power is 210 over 10, 21. So the answer is the fourth root of 21. You cannot write anything down, so estimate. 21 is a bit more than 16 and the fourth root of 16 is 2. So a bit more than 2. 2.1, option B. And look at the 2 you walked past. Option D 21 is the ratio before any root. Option C 4.6 is the square root instead of the fourth. Both are steps in your own working handed back as answers. That is how these options are built. 5 questions with a formula in every one, and I do not think you calculated a single deflection. Which side of the line is it on? What is the exponent? Multiply the factors. That whole method survives without a pen. Go back to official exercise 3 afterwards and do questions 2, 5, and 6 with it. All 3 will take 90 seconds. Technique 4. Type, then size, then value. 3 questions, always in this order. What kind of thing is the answer? A time, a length, an area, a ratio? Roughly how big must it be? And only then, what exactly is it? Most people start at the third, that is why they run out of time. And again, this is the examiner's design. Official exercise 2, question 1. A submarine dives to 10,000 meters. What is the pressure on the hull? 1 bar, 10 bar, 100 bar, 1,000 bar. Each option is 10 times the last, so precision is worthless. The text planted the constant. Pressure rises about 1 bar every 10 meters. 10,000 meters, 1 bar per 10, 1,000 bar in 5 seconds. When the options are a decade apart, the examiner is telling you to estimate. Take the hint. Text 4, subject area, computational sciences. Latency, throughput, and caching. And this text plays dirty in the way the exam plays dirty. It quotes one thing in bits and another in bytes and never warns you again. Paragraph 1. Throughput is how much data per unit time. Latency is how long one single operation takes. And a link can have high throughput and high latency at the same time. Paragraph 2 is the trap, stated openly. Link speeds are quoted in bits, file sizes in bytes. A byte is 8 bits, so 1 gigabit per second is about 125 megabytes per second. Paragraph 3 plants a constant exactly like the submarine. In optical fiber, the signal travels at about 200,000 kilometers per second, and propagation delay is distance over that speed, Tim. Paragraph 4 decides 3 of the 5. The total time is roughly the latency plus the size divided by the throughput, and which term dominates depends entirely on the size. Big transfer, the second term wins and throughput matters. One small record, the first term wins and no amount of extra throughput will help you at all. Paragraph 5 gives the cache, hit rate P, and the average is P times the hit cost plus 1 minus P times the miss cost. Then the table, memory 100 nanoseconds, solid state disk 100 microseconds, a disk seek 10 milliseconds, Mumbai to Frankfurt and back 120 milliseconds. Spend 3 seconds on that table because it is a size chart. Top to bottom is a factor of about a million. A free sanity check before a question is even asked. Question 1. A dataset of 2 terabytes is copied across the 1 gigabit per second link. Ignoring latency and overhead, the transfer takes about A. 4 minutes, B. 16 minutes, C. 4 hours, D. 40 hours. Type first. 2 terabytes is a large transfer, so paragraph 4 says the size over throughput term is the one that matters, and the answer is a time. Size second, and here the trap has to be diffused before any arithmetic. The link is in bits, the data set in bytes. They cannot meet until one converts, and paragraph 2 did it for you, 125 megabytes per second. 2 terabytes is 2 million megabytes, 2 million over 125, 16,000 seconds. Now size it, 3,600 seconds in an hour, so a bit over 4 hours, option C. And look at option B, 16 minutes. That is 16,000 with the seconds never converted. The examiner has taken a real intermediate result from your own working and put it on the list. Question 2. 2 data centers are 8,000 kilometers apart, joined by optical fiber. The propagation delay in one direction is about A. 4 milliseconds, B. 40 milliseconds, C. 400 milliseconds, D. 4 seconds. Look at the options before the question. 4, 40, 400, 4,000 milliseconds. Each is 10 times the last, the submarine again. You do not need accuracy, you need to place a decimal point. The constant is in paragraph 3, 200,000 kilometers per second. 8,000 divided by 200,000 is 400ths of a second, 40 milliseconds, option B. And the table gives the second opinion free. Mumbai to Frankfurt and back is 120 milliseconds, so option D, 4 seconds, is absurd, visible without dividing anything. Question 3. A team wants to reduce the time taken to fetch one small record from a data center on another continent. According to the text, which change is capable of helping? 4 options on screen. They are longer than usual, and that is deliberate. No arithmetic in this question at all. It is the type check standing on its own. One small record. Paragraph 4 settles it in a sentence. For a single small record, the latency term dominates, and no increase in throughput will help. So sort the options by what kind of quantity they attack. Option A offers throughput. Option B offers a smaller file, which is throughput again. Option C offers more links. Throughput a third time. 3 different ways of answering a question nobody asked. Only one goes after latency itself. And paragraph 3 said latency is partly distance over signal speed. Moving the copy closer shortens it. Option D. Question 4. A cache in front of that data center has a hit rate of 0.9. A hit costs 1 millisecond, a miss costs 120. The average time per request is A. 1.2 milliseconds, B. 12.9, C. 60.5, D. 108. The formula is in paragraph 5, so this is arithmetic, but size it first, but it takes 2 seconds and it protects you. 9 requests in 10 cost about 1 millisecond. 1 in 10 costs 120. So the answer sits well above 1 and much nearer 1 than 120. That already leaves one plausible option. Now the value, 9/10 of 1 is 0.9. 1/10 of 120 is 12. 12.9 milliseconds. Option B. And look where that time went. 12 of the 12.9 is spent on the 10% that miss. The rare slow case, not the common fast one, is the whole cost. Hold on to that for the last question. Question 5, the last question of the series. Same costs, 1 millisecond for a hit, 120 for a miss. The team needs the average to fall below 5 milliseconds. Which of these is the lowest hit rate that achieves it? A. 0.90, B. 0.95, C. 0.97, D. 0.99. The formula now runs backwards and you have nothing to write on, so do not solve it, size it. The move comes straight out of what you just noticed. The misses are the whole cost, so ask what the misses alone are allowed to be. A miss costs 120. For the average to stay under 5, the misses on their own must contribute less than 5. So the miss fraction has to be under 5 in 120, about 1 in 24, a little over 4%, which means the hit rate must be above about 96%, and 2 options are already dead. Now check the survivors, because the question asked for the lowest that works. At 97%, the misses cost 3% of 120, 3.6, and the hits add another one, 4.6, under 5. 99% works too, but it is not the lowest. Option C. And sit with that number, because it is the most useful thing here. Going from 90% to 97 barely changes how often you are fast. It changes the average from 13 milliseconds to 4.5. 5 questions. In 1, you did no arithmetic at all. In 2, the size check killed most of the options before the arithmetic started. In the other 2, sizing first is what stopped you accepting your own intermediate result as the answer. Type, size, value, in that order every time. 4 techniques, here they are together, and this is the part to screenshot. 1. The sentence that decides. Every answer is a sentence in the text. Find it before you judge and read the because, not just the conclusion. 2. Split the option. 2 claims means wrong if either half is wrong. Be sure of one half and let it kill the rest. 3. Move the lever. Read the formula as proportions. On top grows it, underneath shrinks it. The exponent is how hard. 4. Type, then size, then value. And when the options sit a decade apart, stop calculating and estimate. And 1 plan for the 90 minutes themselves. Read each text once for furniture, where the formula is, where the table is, what each paragraph is for. You cannot take notes, so a map of locations is the only thing you can carry. Then let each question send you back to the right place. If a question resists you for more than about 90 seconds, mark it, answer it anyway with your best guess, and move. A question you leave for later is a question you may never see again. And never leave a blank. The official instructions ask you to guess. There is no penalty. A blank is the only answer guaranteed to be worth nothing. Before we finish, look at what happened in this hour. You answered 5 questions on historical linguistics, 5 on chemical equilibrium, 5 on the bending of beams, 5 on network latency, 4 subject areas, and almost certainly at least 3 of them are not yours. And you did not need a single remembered fact in any of the 20. That is not a trick of how I wrote them. That is what page 5 of the official document promises the exam will be like. So when the paper opens on a subject area you have never studied, and for most of you it will, you already know that is survivable. You have just done it 4 times. That is the series, figure sequences, mathematical equations, Latin squares, and the general academic module, 4 videos and the whole exam. Everything here comes out of the official preparatory materials, and the link is in the description. Go and read them yourself, not because I got anything wrong, but because that is the document your exam is built from. 26th of September. You have time and now you have a method. Go and practice. All the best. And I will see you on the other side of it.